I am an organometallic chemist and I lead a fantastic group of young researchers focused on understanding organometallic processes relevant for sustainable catalytic transformation. Our goal is not only to provide critical mechanistic information on well-known reactivity. We have a more ambitious goal that we call a U3D goal. We want to understand, discover, design and develop novel and sustainable transition metal catalyzed transformation. A priori, this order may seem not intuitive because what we try to do is to understand a process at first place, but we have a reason. We want to trap reaction intermediates and use them as knowledge building block for rational design.
My work is related to the use of bimetallic systems, in particular palladium and silver ones, as an alternative to palladium catalyzed cross-coupling reactions. The majority of our reactions are prepared inside the glove box under inner conditions to avoid the presence of oxygen and moisture, especially for working with the silver complexes.
We envision fundamental knowledge as a really powerful tool. The foundation of our research is based on a really simple idea. The successful performance of a catalytic cycle relies on the efficiency of each intermediate involved in the elementary steps. This may seem obvious but normally is overlooked, and this can be a completely game changer for not efficient transformations. So we want to trap intermediates to explore novel reactivity and overcome limitations.
In the lab, we are focused on understanding how chemical reaction works, and in particular, we would really like to understand how CP* cobalt complexes can catalyze some very important transformations. We have developed the technology to isolate what before were highly reactive intermediates that could only be proposed and never detected, but now we have come to the point where we can have crystal structures as such and really understand them. But we would like to think about these complexes not only as transition metal complexes, but also as knowledge building blocks. If we are able to understand how building blocks interconnect in a working reaction, maybe we can use this knowledge to engineer new reactions and new pathways that were otherwise impossible because we didn't know how these pieces came together in a working reaction. And this is what we want.
My group has a really multidisciplinary background, ranging from organic synthesis, organometallic chemistry, different analytical techniques, and a whole bunch of physical organic tools.